here's some more examples of differentiating with natural log. And so this is ln of x squared plus 3. There's no properties of logs you can do, so you just do differential derivative of ln is 1 over whatever's inside. Then by the chain rule, derivative of x squared plus 3 is 2x. And so you just get this. In this situation, you can use a property of logs to split it up to a difference, ln x minus ln x plus 1, derivative of ln x, 1 over x, minus derivative of ln x plus 1, 1 over x plus 1. That'd probably be okay, but it's only two fractions, so you should get a common denominator. And so denominator is x times x plus 1, numerator's up here, and then we end up just getting 1 over x times x plus 1. This is going to require quotient rule, so you square the bottom and then write it up here, times the derivative of the top, derivative of ln t is 1 over t, minus the top, times the derivative of the bottom, derivative of t is 1, and then t and 1 over t cancel, get 1 minus ln t over t squared. Alright, for this one, what you can do is put the ln there. On the inside, this ln x to the n, I can put the n and put it in front, so I've got n ln x. So now, looking away from the outside in, derivative of ln is 1 over whatever's inside, so 1 over n ln x, times the derivative of n ln x. Well, n is a constant multiple, so n times the derivative of ln x, which is 1 over x, so it becomes n times 1 over x, which is n over x. So now as you can see, the n's cancel, you get 1 over x ln x. And therefore, the n value does not matter at all. And in this particular problem, n was 2. It was actually ln of ln x squared, but n doesn't make any difference at all. Here we have ln x, and so 1 over ln x times 1 over x, 1 over x ln x. So going back to 51, right, it's the same problem where in this case, if you see that n is equal to 1, ln of ln x to the first power. 55. Now we can use some properties of logs to split up into a difference, and also the square root's going to put a half in front there, minus ln x. Half's a constant multiple when I differentiate, and then I do 1 over whatever's inside times the derivative of what's inside by the chain rule, and then minus derivative of ln x, which is 1 over x. Simplify a little bit, and I get to here. If you do get a common denominator, since it's only two fractions, you can get it all the way to negative 4 over x times x squared plus 4. Now a couple more with logarithmic differentiation. This is where you could do this without a log, but it's nicer to have the log, so we introduce it. That allows us to use properties of logarithms to split this guy up. So the ln y is now equal to ln x plus 3 halves, because it's x1 comes in front, ln x minus 1, and then minus 1 half ln x plus 1, 1 half because it's the square root. Derivative of ln y is 1 over y times y prime, so y prime over y. Derivative of ln x is 1 over x, derivative here, 3 halves times 1 over x minus 1, and then minus 1 half times 1 over x plus 1. Multiply the y to the other side, so all of this stuff here gets multiplied by y, and y, of course, was originally up there. And finally, 88. Another logarithmic differentiation problem. You don't need to use it, but it's certainly convenient to do so. So you put a natural log on both sides, then this all gets split up. So positive for the top terms, negative for the terms you're dividing. Then y, you differentiate y prime over y. Then each one of these, there's no chain rule for any one of these. And then we multiply the y to the right. And so we take all this, multiply it over. This is 4 fractions, so I don't bother trying to get one single fraction. It's probably not worth the effort.